All right, today we're heading out about 1,350 light years from home, over to the constellation Orion. It's home to one of the most beautiful and, well, eerily named objects in our night sky, Messier 78. Now, this is what's called a reflection nebula, basically a giant cosmic cloud of dust and gas that's just reflecting the light from stars nearby. And all that glowing gas is how it got its famously spooky nickname. Yep, people call it Casper the Friendly Ghost. And when you hear that, you kind of picture something quiet, right? A gentle cosmic specter just floating through space. But for decades now, astronomers have been digging into this region, and the evidence they've found, well, it tells a very different story. So what's really going on inside this celestial phantom? To really crack this cosmic mystery, we first need to zoom out a bit and see the bigger picture. Because it turns out, our ghost isn't alone. Okay, so take a look at this. What we call Messier 78, our ghost, isn't some lonely little cloud floating by itself. It's just one bright spot in this absolutely colossal structure called the Orion B molecular cloud. And this whole region is crisscrossed by these huge, twisting filaments of cold gas and dust. So yeah, this is not the quiet home of a ghost. It's something way more dynamic. So how in the world do you get these massive, stringy structures? Well, the process has an amazing name: gravo-turbulent fragmentation. Just imagine a gigantic gas cloud that's churning with supersonic turbulence. It creates this crazy, chaotic web of shock waves. And where those shock waves crash into each other, bam, the gas gets squeezed, creating these super dense knots and filaments. And that, right there, is where the magic starts to happen. Okay, so we've got our scene. A huge, chaotic cloud full of these twisting filaments. The next step in our little investigation, we've got to look for clues hidden deep inside, signs of what all this chaos is actually building. 70. What's so special about the number 70? Well, this number, it represents the first huge clue in figuring out what the Ghost Nebula is really all about. So what is it? Back in 2001, astronomers used a special camera that can see through all that dust, and they found 70 incredibly dense clumps of gas. Now get this, these clumps haven't ignited into stars yet. They're called prestellar cores. They are literally the very first stage of star formation. Think about that. The cloud isn't some empty, ghostly thing. It's basically pregnant with dozens of future suns. And we're not talking about tiny specks of dust here. These prestellar cores are serious heavyweights, ranging from about 1/3 to 5 times the mass of our own sun. On average, they're about 5,000 AU across. That's thousands of times bigger than our entire solar system. So the takeaway here? These are huge clumps of stuff, just sitting there, right on the verge of collapsing under their own gravity to become brand new stars. All right, so we found the stellar eggs, right? The seeds of stars that haven't hatched yet. But are there any newborns already in this cosmic nursery? It's time to find the main players in this drama. And you know, this isn't some new investigation. Astronomers have had their eye on this region for a long, long time. In fact, the hunt for baby stars here goes all the way back to the early 1960s. Back in a landmark paper from 1962, two astronomers, HERBIG and Coohe, took a close look at this area and they found something wild. 45 stars that were just acting up. They were behaving erratically, flaring up and dimming. These were young, volatile T-Tauri stars, pretty much the celestial equivalent of toddlers throwing a tantrum. This was the first hard proof that Messier 78 was an active stellar nursery. Today, we call these things young stellar objects, or YSOs for short. These are stars in their infancy. They're still basically bundled up in their baby blankets of gas and dust, and they're still actively feeding and growing. So we've got the seeds, and now we have the babies. Okay, we've got the crime scene, those huge filaments. We've got our suspects, the young stellar objects. Now we need the smoking gun. We need absolute, undeniable proof that these baby stars are causing a ruckus. And that smoking gun has a name, a HERBIG-HARO object. See, when a baby star is born, it doesn't just suck stuff in. It also blasts out these incredibly powerful focused jets of gas. Think of them like cosmic fire hoses. And when those jets slam into the gas cloud around them, boom, you get these glowing shockwaves. These are the bright, telltale signs of a violent stellar birth. And here they are. In 1999, astronomers confirmed they exist right in the heart of M78. On the left, you've got HH443, looking like a bright knot with a little tail. On the right, That's HH452. Now, listen, these are not ghosts. These are cosmic impact sites. This is the visual proof that brand new stars are literally shooting jets out into space. And this quote from a 2012 study just paints the perfect picture of the chaos. It says that it's actually hard to figure out what's going on because the center is so crowded with baby stars. Basically, what they're saying is that the whole area is such a mess of stars and jets that they can't even tell which jet is coming from which star. It's not a quiet neighborhood, it's a cosmic free-for-all. All right, it's time to wrap up our investigation. We've looked at the scene, we've identified the actors, we've found the smoking gun. So what's the verdict on Casper's little secret? Here's what we now know for sure. 1. The ghost is just one bright patch in a huge, turbulent cloud. 2. That cloud is jam-packed with at least 70 seeds of future stars. 3. There are already dozens of young, active stars lighting the place up. And 4, and this is the big one, these baby stars are firing off powerful jets all over the place. So, the final verdict? That gentle, friendly ghost is a myth. Messier 78 is actually one of the most chaotic, violent, and incredibly creative places in our entire galactic neighborhood. It's a star factory running at full blast. And that leaves me with one last thought for you. We've just seen how these stars are born, in all their messy, violent glory. But what happens next? What's this place going to look like in a few million years, when all these little stellar toddlers finally grow up and blow away all the gas they were born from? Now that is a story for another day.